Okay, we have a few more people that are joining, but we're going to go ahead and get started. Again, my name is Tom Gaunt. I'm with Geometric Solutions, and I'm hosting today's webinar. It's Untangling the Rat's Nest, Plant Simulation. And if you can think of a visual of a data room where wires are going everywhere as being that rat's nest, and then envision a data room that's probably properly taken care of, where every wire is routed correctly, being really what plant simulation does. What it does for the manufacturing floor is the same thing. We have with us, before I get started, just a few housekeeping things. In the bottom right-hand corner your uh, of your screen, you'll see an area for questions. We will have time at the end for a few questions, so feel free to type your questions in there, and we'll make an attempt to getting those answered for you. And Curtis, if you want to move to the next slide. Our speaker today is Curtis DeSaley. He's our Director of Technology. And if you've spent any time with Curtis, you know he's the type of guy that gets under the hood and wants to understand how things work. You know, I see some of the projects that he does with his kids at home with robotics, and it's amazing, you know, the amount of knowledge that he actually has in varied areas. But with that, we'll turn it over to Curtis. And Curtis, you might take a second or two and share your background.
Thanks, Tom. So welcome everybody. My name is Curtis DeSaley. I've been around this product here is a simulation tool, and I've been around the simulation game for over 35 years. You know, I actually, 15 years ago, I used to work for Siemens selling software, and since then I've been with Geometric Solutions selling Siemens software. So these tools are near and dear to my heart, and I get all excited about that. So this is going to be more of a technical focused on one of the products that Siemens has, but I'm going to talk to you about what the software does and the problems it can solve for your customers. You know, why would your customer be interested in it? And then, you know, the goal here is not only to sell the software, but to sell hardware. And we're going to talk about how, you know, we can support each other using this software and how the hardware can be used with the tool in virtual commissioning, and you know how we can position it to strengthen sales from both the FA side of Siemens and the PLM software side of it. So with that, I'm just going to kind of jump into it here. And you know, there's some industry drivers out there. You know, on the left here, I have corporate things of compressed timelines, lower cost, productivity, but the actual manufacturing engineers, this is all around the plant. Yeah, they're worried about meeting their production targets. You know, are they going to have any bottlenecks? Are they going to have any delays? So what we want to do is, you know, mitigate risk. And to do that, I'm going to be using simulation tools. So if we look at a standard timeline where the left is just, you know, we have a concept and you finally go through product engineering and production engineering, and then you get into executing it on the plant floor. You know, the ability to change is easy when it's up front, it's all electrons, and the cost of the change is a lot cheaper. You know, once it's in production, it costs more to change it, and I've already invested some materials in the tooling and such. And you know, after engineering release, all the manufacturing concerns are addressed, and what we want to do is use some of these tools to perform the manufacturing activities earlier. And through computer simulation, I can actually simulate my plant floor, how it's going to work, and how my mechanical and electrical systems are going to function on that plant floor. So here's just a quick little video from Siemens, but it starts showing here a digital twin of the plant, an actual plant. You know, we're trying to actually get insights to how the plant is going to operate and perform. And there's this Technomatic suite, which is one of the tools for logistics, specifically is plant simulation. And We're basically trying to model production systems and eliminate any type of waste, whether it's in resources, time, material, and capitalize, on that investment you're putting in there. What kind of machines do I need to buy and tools? What kind of energy usage am I going to be using on the plant floor with these machines and the hours that it's being done? Throughput targets. Everybody has a goal of making X amount of units a day, an hour, a week. You want to make sure we can meet those targets, and I can simulate that using this kind of tool. So my elevator pitch, if I told you I had a crystal ball that lets you see problems with your future product launch, would you be interested? That's what this tool does. It's a crystal ball that lets you see problems before they happen on your plant floor, and you can address them and correct them through the simulation, test out different things, and see what the best path is forward. And then that's the design you want to take into production. So if you're on the left here, 65% of your people and 80% of your costs is in the plant. That's not where I want to find my problems. I want to find them earlier. A little bit of change up front will minimize my costs and increase the profits using these kinds of tools. So what is it? Plant simulation. It's a dynamic computer model of, a system. So whether it's an entire plant, a line in a plant, a series of plants, it's just, we're going to explore the characteristics that are going on in it and optimize the performance. And the optimization could be for throughput. It could be for manpower, number of AGVs I need, number of, robotic cells I need to make sure I meet my targets for that plant. And then, once I have it, I can run experiments and what if scenarios without disturbing the the existing plant, because it's all virtual here. And then from that, what if I can, get my best plan forward and try to make sure that I meet my production launch dates. So, what plant simulation, you got a real system and a plan, but what we do is create a simulation model of it, and then we can optimize the characteristics. If you look at the right, the white was the path that people were walking to get parts and move things through a system. Once it was optimized, it was much leaner, faster, and what this does was this computer simulation model is an intelligent foundation for making business decisions. It's no longer, the 500-pound gorilla in the conference room that pounds his fist and it goes that way. I got numbers and proof that shows why plan A versus plan B is better, and I'm using real world numbers and processes to simulate this. So here's just a quick demonstration of this. What I'm going to show you here is the tool. When I get started, there's example models. I can go into, there's demo videos, there's tutorials. It's right inside the software, but I'm just going to start a new model from scratch. And it's a pretty simple tool. So I'm going to have a starting point, and they call it a source and a drain. Now this could be the loading docks to in and out of the plant, or this could be just the entrance and exit of a cell with some dunnage. Inside this line, I'm going to create two stations, but I can put pick and place machines, buffers, sorters. I have all types of standard factory automation equipment. Right? So, but what I'm going to do is just say my parts are going to come in from my source, go to my first machine, go to my second machine, out the back end, and then I can put other things in there. I can put people. I can put shift calendars for when they're working. I can, here I'm just going to grab a chart because I want to get some information, but I can run bottleneck analyzers, find where the bottlenecks are, Sankey diagrams to see flow, energy analyzers, experiment managers. I can do design of experiments, and optimization wizards that help me figure out how to solve my problem and optimize things. So what I'm going to do here is just say I'm going to run 20 days worth of production, and I'm just actually going to do the slow at first here to show, but you can see parts are going to move from one station to the next, and the color means something there. Yellow means it's kind of waiting, because the first one's waiting for the machine to open up. The machine works on it, and then it goes through the system. I'll speed it up. I just ran 20 days worth of production, and I can real quickly look here, statistics, and I'm doing 60 jobs per hour, which was what the machines were rated at, and all is good. I can do this bottleneck analyzer, and I can see here, all these are waiting for the next machine to take it. 100% working, 100% working. And this is starving until the machine before me hands off the parts. So it's telling me that kind of information. But what I want to do is these machines, machines on the plant floor aren't always up 100% of the time. I'm going to make it really bad. I'm going to say it's going to be only up 80% of the time. And then I'm going to run my statistics on this. And I'm going to look at my output. And 80% of this should be at 48, and I'm at 39.57. I'm 40% instead of 48%. Why am I so low? Well, if I look at this guy here is, trying to feed this. I got 20% downtime, but I'm waiting on the machine that's down next to me to hand it off and vice versa. Sometimes the second machine is waiting to go, but the machine before it is shut down. So what I'm going to do here is just do a quick chart of this. And you can see this is kind of stacked up. Here's those two stations, and I can see I'm, running 20% downtime. But here I'm waiting to hand it off, and the other one's waiting to receive it because the other machine is shut down some of the time. So what I want to do is try to optimize that. Knowing that I have 80% downtime, how can I fix that? Well, a simple way is I'm going to put a buffer in the middle here. So I simply just put a buffer in. I'm going to rerun my results, and you can just see visually here, I'm much better. So I'm leading towards the right thing here. So what I want to do is look at my throughput here, and I'm not at 48, I'm at 46 roughly. So how can I make that better? Well, what's the size of the buffer? Right now, there's only 4 parts in the queue. I'm going to try 100 just to see what that works like. And if I do my analysis here, and I'm almost perfect, right? So it's somewhere between 4 and 100. But I can use a tool like this to find out where I got a bottleneck on the plant floor and fix it and put in equipment to solve that. So, so that's simplistically what this tool does. So I'm going to go through a case study here. So we had a customer that was doing TVs, and a couple years ago they wanted to add 3D stereo. So this is the barroom napkin sketch, So they had a main board, they had displays and power strips, and this portion in yellow here is where they're adding the new 3D stereo line. And so what we did is we modeled it up over the top of that. It's going to be done in 2D or 3D. We just simply did it in 2D because this was a 2D sketch. So we have pallets coming in to a set of conveyors. And when the main boards are being done on these sublines, they're going to be pushed in. And once it has something, it's going to push it through the system. So you can see the conveyors moving the pallets along around through the system, and eventually it gets to the bottom line here where they do quality inspection, localize it for countries, and then pack it. And then we can see the throughput once the first parts come off the end of the line and see what type of throughput we have. So I sped it up here, and we're getting 900 of throughput out. But if you notice here, you can see there's like a bottleneck here. These carriers are going up to this point and then stopping, and it's coincidentally exactly where the new 3D stereo line is coming in. Sankey diagram doesn't help us much. It's just showing us the part flow, which is kind of what we see there. Sometimes if you have people walking, it's more impressive or it displays more. I'm going to come down here and take a chart, and I'm going to take these stations on the main line before and after this and drag it into this chart and actually see what's going on. So I can see here that, there's a bunch of blocked portions where I can't hand off, and these are waiting. So something's happened between 5 and 6, because before 5 I can't hand parts off, and at 6 I'm starving for parts. So why is that happening? And that's exactly where the 3D stereo line's coming in. I do my bottleneck analyzer, which is going to show up on every station. It's very cluttered, so there's ways to actually look through this, but sometimes it's very fast and easy to identify something. So what I'm going to do here is I'm going to explore some attributes. And what I'm going to do is grab everything in this new 3D stereo line and find out why something's happening in this line that's affecting the main line. And if I show what I want to see, the attributes, I want to just, I got tons of attributes I can pick off of any of these stations. But I want to do processing time. And if I take a look at my processing time, I can see my processing time is actually higher than my main line. So it's actually going slower than my main line, so it's causing a problem. So now that I know this, I can do a few things, start looking at it. So my throughput for the day is roughly 2,000, which is good, but it's not really what I want. So what I'm going to do here is I'm going to look at my shift calendar, and my main shift goes from 8 to 5:15. But I do a separate shift calendar just for this line. I'm going to start them at 7 in the morning, put an extra hour onto it, and see if that helps. So I'm going to put a buffer in here with 1,000 capacity. I just want to throw something in there. And then what I'm going to do is actually show what's in the buffer. So between 7 and 8 o'clock in the morning, I get 250 parts in it. And you can see time's going on, and it's being depleted as the day goes on because the main line's going faster than the subline. You can see my breaks in there, my lunch, but I'm ending up at 5:15 instead of 5:30. I've increased my throughput, which is good, but I'm running out before the end of the day is finished. So maybe instead of working a 9-hour shift, I come back in here and add an extra few minutes, and I'm going to start at 6:50 and hit apply, go through the analysis again. And you're going to see here that 300 parts got in the bin, and through the magic of a demonstration here, it all works. So I have enough parts in my my buffer to satisfy the workload. So I'm doing good. So I'm getting throughput, but one of the things we noticed was when we did this, you can see there's a blockage here. I got all these carriers here that are sitting, and they're going and stopping at the first one. And why do we have such a blockage? So the original analysis was to talk about the 3D stereo line, but we found this problem and we started looking at this. So I want to analyze throughput per day. I'm going to do a design of experiments, and I'm going to say carriers. I want to go from 10 to 100 in increments of 10. They had 60 some on the floor. And they want to take the line speed of the conveyors and go from 1 to 5 meters per second and run the experiments. So I'm going to start this, and it's going to go through and do all different combinations of this. And when I get done, I get this nice little report, does a screenshot of what I was looking at. And you can see here, I got 10 carriers at 1, 2, 3, 4, 5 meters per second and their results. And it did this whole matrix of combinations. And you can see here at 10 meters or 10 carriers, it wasn't enough, 20 wasn't enough, 30, we're getting up there, and there's the line speed changes, we start looking at it and we try to find, experiment number 12 here, so 1,215, that's very close to where we want. And, we are getting higher throughput from these 30 carriers. Well, what we did is we worked with the customer and said, all right, so what you need to do is take the 67 carriers and go down to, 30, it was actually 32 because we did a finer analysis after this because we went from 20 to 30 to 50, in big 10 unit jumps. But we said go down to 32 carriers and go to like 2.2 meters per second. And they were running at 4 meters per second on the line. They basically said, you mean slowing down the line is going to make it faster? We don't believe you. Well, a month or so after that we gave them that result on a Saturday, they did it. And they called us back on Monday and said, oh my God, you can't believe it. We're actually getting more throughput because they slowed the line down and took some carriers off. What that did was that customer using this tool to actually improve the system that they had, the system they've been running for a few years, they got 16% additional output without any people or equipment. They figured they got an extra 318 TVs units daily. That equated to 15 million annually that they made profit just from this change on optimizing a system that they already had running and they were happy with. So we use this tool to prove out things can happen, get better. So another case study. I don't know if anybody's ever heard of an Eaches plant, but this happened to be for a potato chip manufacturer, and they were making these plants that provide boxes that are, each separate for each customer. Mom and pop stores, your little 7-Elevens, those kind of places, they need, specialized orders. They're not ordering a whole pallet. So they were going to build all these plants around the country and use robots. We analyzed it. And what happened was we figured out if we added 2 extra robots and a bypass lane, they almost doubled production going through the same plant. Because of that, instead of making 90 some plants, they put in 63 plants. At $3 million for the plant plus the land, you know, it was a mega savings for this customer, mainly because they had a lot of volume of plants. But it was for minimal extra investment. We doubled the production output using this tool and proved it out through this tool. And that's one of the powers of this tool. So we had pallets, we had pick and place machines that started putting it on the conveyors and into the boxes. So this happens to be a Agv Tracker. So this is, you know, showing you some applications. This is a, you know, if you have customers that are putting AGVs in, there, you know, this is a great application for this tool because each AGV has a PLC on it. There's usually a master controller. We can test all that logic and the switching up front and actually tie in the PLCs, whether it's hardware or I'm going to call it software in a loop where we simulate the PLCs to this tool and actually test the coding that goes into that. So, you know, if you're looking for a customer that you're trying to convince to go from whatever type of controllers there are to a Siemens controller, using tools like this, I can validate that all through software. I don't have to have the physical hardware, and I can actually simulate how the PLC code is going to work and run. So this little animation here, you can see the AGVs. This loop over here is a small loop, and I got 3 AGVs, but I got a longer loop that's delivering it to this line. Well, do I need 4? Do I need 5? I can test that out. Also, I have a battery charging station here. So I can actually take the time and charge the AGVs and see how that drains the system, and do I have enough AGVs in the system to keep the plant, you know, satisfied for the amount of, you know, parts that have to be used. So this tool here can actually answer those questions. And I've actually seen manufacturers that make AGVs use this tool to prove that when they make a bid on a job, they know they need 7 of these or 12 of these or 40 of these systems in there versus guessing and then outbidding, you know, bidding too large and not getting a job, or bidding too small and then costing them too much money because they have to add AGVs to make it work. So another application, customers that have high bay warehouses. You know, it's a classic problem of where do you stack stuff? How do you get it in there? You got these elevators going up and down these rows here that are stacking parts. What goes into what slots for speed and optimization? I can actually simulate the putting everything into the high bay warehouse and taking it out to make sure that can handle the volume, and these elevators are fast enough or enough of them, or we have enough cells to store everything in. So that's another great application. So if you hear customers that have, you know, a brownfield or greenfield plant, I can use this tool to simulate the whole plant when I'm putting it in. If they got any type of automated, you know, AGVs, I can put that in. And the cool thing is once I'm putting these things in, I can tie them into every sensor and PLC to test out the logic for the PLCs to make sure that these tools are operating the way that the PLC wants them to operate. For example, you know, this is a pick and place machine over here that this stays there until the part's gone. Well, if this doesn't fire, and I might have 4 or 5 AGVs sitting up here, and I can test the logic for communicating between these two devices to make sure that, you know, parts are moving. So when the parts disappear from the AGV, the part presence sensor then sends a signal to the AGV that you could move forward, and we can test all that stuff out. So, you know, how do you mitigate risk? You know, those risks that we were talking about earlier. You know, what we do is we use a crystal ball, look into our future, use this tool called plant simulation, or we can do it as I call it, the traditional way. You know, I never liked those ways there. I actually preferred the lucky horseshoe. I think it's better than the cross fingers one by double at least. But so with that, does anybody have any questions? You know, for me on this?
Curtis, thank you for your presentation today. I get excited every time I see this. In my view, this product probably offers the largest return on investment of any of the simulation tools offered, because you're working plant wide, and little changes that are made here and there have big payoffs. That 15 million on that one example, that was their net increase. So there's tremendous returns that are capable with this tool. We're looking for questions to come in, and I see two. Curtis, somebody's asking, what is a target customer for plant simulation?
Well, the ideal target customer, that really can get into this is anybody putting in, building a new plant, going from one plant to another and increasing the size and making sure they want throughput, or just actually putting a new line in. This is a great target customer because it's all, a blank slate, and then we can optimize that blank slate. Those are my favorite customers to go after. After that, the next grouping is anybody that has complex systems that are automated. And I'm going to pick on AGVs. That's one of my favorites for this tool, is I can simulate the AGVs. This is what they call a discrete event simulation tool. The event has to happen, so that part placement sensor has to trigger for that AGV to either take off, or stay. And so we can simulate that through the plant, and it's at the plant level. It's not the individual machine and what's going on inside that CNC station or whatever that machine is. It's basically part gets delivered to it, the machine works on it for 30 seconds, 10 minutes, whatever the timing is, and then the part comes off. We can put plus or minuses on that and say it goes from anywhere from 10 minutes to 11 minutes, and we can use that as a simulation. So this is for customers that are actually putting lines in. It's my favorite customer to work on it. But then I have other ones that are looking at it to figure out what went wrong, and that's this TV case where they added the 3D stereo line, they weren't meeting the targets.
So Curtis, there's a follow-up question to this, and it is to get more throughput with a question mark. Obviously, I think that is one, but there are other benefits too, right?
Yep. Well, one of the unique things about Geometric Solutions, my parent company is an engineering firm. We use these tools every day. We use it to make money. We were challenged by one of our OEM customers. It was a car manufacturer, and they were putting two lines through an existing plant. They had a Pontiac and a Saturn, two lines that don't exist anymore. But anyways, they wanted to add a third model in. Not only did they want to add a third model, they wanted to get 15% increase in production. So using these kinds of tools, we can prove out whether these changes are going to work or not in the simulation model. And, it's just, it's meant for, to basically prove that these changes are going to work versus putting it on the floor and going, oops, that was a nice swing and a miss. And so that's the great thing about simulation is I can test it out, do my what ifs, and I can actually test out method A, B, and C. Maybe A, everybody agrees is the right way, but it's very expensive, and B is cost effective. And if it gets us 90% there, now it becomes a business decision. Do I get 90% of the improvement for 10% of the cost, to the changeover? So that's one of the great things about this tool is I can test all these scenarios and then make good business decisions on hard numbers.
So I would quickly add to that some of the ancillary uses for the tool, like energy consumption. Yep. In today's world with the cost of energy, being able to know when to idle machines, to turn them off, start them up in the process, can see 10 to 15% savings in energy costs. And then there's the whole piece with we showed discrete items today, but there's also fluids. You can map the fluids out as well. So
from breweries to dry goods, rice, stuff like that, how to package them, ship it through the plant, and make sure they, it's all optimized for throughput. And throughput's the most common usage, but it can also be used to optimize resources, whether it's the worker pool or how many AGVs or, how big the warehouse has to be to store all my data or all my parts.
Correct. And then I have one more question that's queued up here. And I think this is really appropriate and a good question is, we talk about plant simulation, mechatronics concept designer, and process simulate. What's the difference?
Oh, yeah, that is a good question. I got an educated, person out there. There's Siemens, I'm going to say, has 3 levels of simulation. One is aimed at the plant, and it's kind of a macro simulation. Mechatronics concept designer is aimed at a machine. So if I'm doing a CNC machine and opening up doors and all that good stuff and rotating pieces inside there, I can do the machine at that level, and it's focused on that because it's very detailed and it's very micro oriented. Process simulate somewhere in between. Process simulate is good for cells, and process simulate is really good for robotics. Plant simulation, I can model anything in the plant from workers to fork trucks to conveyors, all these things. We did a simulation here recently for a airport to get luggage from where they're picked up to the planes. Those kinds of things can be done with a plant simulation tool because it's looking at a larger macro system, and we're using input from the machine manufacturer of how long the cycle time is to do that machining operation when a part or product comes to that station and then comes back onto the line and moves through the line. So plant simulation, macro plant, and MCD is micro machine, and process simulation is good for cells and really good when there's robots involved.
Okay, thanks. That's it's a big question, really, and knowing when to use the right tool is important. No other questions at this time. I did want to finish up by encouraging the group to come back on August 14th, or I'm sorry, August 28th. Scheduled right now is Process Simulate Automation by Digital Simulation, but we're changing up due to some commitments. And so we're moving up Who Owns Quality, talking about VSA and DPV with a quality application, and then the Process Simulate one will take its place. So we're flipping those two. So on the 28th will be VSA, and on September 11th will be Process Simulate. And we'll update our information to reflect that. So with that, I want to thank everybody for attending, and have a great day. Thanks again, Curtis.
Thank you, everybody.